Hello, it's me, Chandler Klebs, and this is another one of my unscripted rants. Now, in this one, I'm going to be talking about computer programming, which I know that almost nobody cares about, and this is really frustrating for me because I love computer programming, and it would be nice if I had people I could share my stuff with that could appreciate and learn from this stuff. And I don't have, okay, first of all, I hardly have any friends. And those people I do have in my life certainly don't understand computer programming, except for my friend Ben, who, well, he's over in I can't remember, is it North or South Carolina? Oh man, I don't know. And he's actually a computer science major. He's like the only one I know that I've ever been able to talk programming stuff with. But computer programming is actually very exciting. It's actually quite a hobby of mine. I don't know if I could ever make a career out of it because that means working with people, and I just hate working with people. I prefer to just rant at people through YouTube videos, but I don't like interacting with people. Scares me at work too. Okay, so now a lot of my videos that I have done recently, I haven't done very many, have been short, and the reason why my videos have been short is because it's always I'm getting ready for work. And I usually only record videos when my mom's out of the house. And the problem is that she never leaves, except sometimes in the mornings, but it's just before I go to work. So I never get any alone time, almost never. In fact, today I canceled my counseling appointment so that I could sleep in instead of talking about my emotional problems. Because what's there to talk about? I'm an emotional, screwed up mess. But how I feel about that is I don't want to deal with that. I'm gonna die someday. I want to spend my life doing the things I like doing. I want to sing. I want to dance. I want to play video games. I want to do my computer programming. I want to do stuff I like to do, and I don't get enough time to do that. And I'm sort of having a third life crisis, a third of a life crisis, instead of a midlife crisis, because I think you have to be middle-aged for that, and I'm 31, but I'm just having a little bit of a crisis because I'm 31 and I'm feeling old, and I feel like I'm not at the place in my life where I want to be. So yeah, but that's enough about me. Anyway, I want to get on to some very interesting things here. Okay, I have 3 books with me. Okay, I have the C programming language. This is the first edition, and it was published in 1979. And it's smaller than my other programming books by far. But yeah, I really like this. Whenever I get a chance, which is very rarely, I will take this book and I will go to somewhere like a restaurant. Sometimes I'll go to Burger King, sometimes I'll go to the Jack in the Box and just get a drink or something, because I want somewhere where my mom will quit yelling at me so I can read, because she never shuts up, and I need to read, and I need quiet and solitude so that I can learn how functions and structures and pointers and all that good stuff works in C. And the C programming language is the programming language I have the most experience in. It's actually my second programming language. My first was actually BASIC. I did QBasic and I did Free Basic, but C I like. Okay, so first a short rant about why I like C. C is the lowest level language there is. I like low level languages because I'm a math nerd, and through the years I've done various things involving, I've made functions before that will convert will display integers in binary, which is ironically something that the C programming language doesn't support automatically. It displays numbers through the printf statement in decimal, octal, or hexadecimal, but not binary. So it's actually a little bit weird. But yeah, I have a lot of experience in C, and I like it because it's I'm going to declare integer variables, and I'm just going to do some weird stuff, do some integer sequences. So most of my C programs are extremely small. The functions will usually fit on just one page, one screenshot. I screenshot stuff and send it to and upload it to Facebook. Like when I have good source code, and I use Notepad++, and people who watch my Facebook will notice every once in a while I'll have screenshots of Notepad++ with my C source code, and you'll see the syntax is color coded. It's syntax highlighted and color coded based on what it is, and that's why I use that text editor, because it's like Notepad, but it has syntax coloring and cool features and has line numbers. It's very helpful. It's the text editor I use for everything. Okay, now C has been around for a long time, and now C++. I really don't know much about C++. I really don't. Now, I've read through the whole book that I just showed you, and I've read through this whole book too. And keep in mind, this is the second edition. I think both of my books are outdated. I got them both of them I got them used for less than $10 off of Amazon. They're worn out. They've been used. They're very old. The pages are aged. But yeah, I mean, it's still, regardless, it's still hundreds of pages. This is a much bigger book. This covers so much about the C++ programming language, and someday I want to get a newer edition of the C programming language and the C++ programming language, and it's really good. Now, this final book, and this is probably the biggest one, this is the Java programming language, and I believe this is the first edition of this book. And it covers just about everything about Java. And this book is way bigger. Like this one here is like over 300 pages. I think it's bigger than even the C++ programming language. Plus, it's a bigger size book. So even if it was the same number of pages, the pages are much bigger. Now, Java is a language I've toyed around with. I've done some things in Java, but of course, all the things I've ever done are pretty much the same programs I write in C or C++. Like, I'm going to display the powers of 2, or I'm going to write a program that displays the prime numbers, and I do that. I'm really good at writing those kinds of programs. Now, my opinions of C, C++, and Java are like this. Okay, so C, it's very low level. All you've got is integers, and you've got functions you can call and stuff like that, and you can do all sorts of amazing stuff. And I love that. I'm very good at that. C++ adds a lot of features. It has classes. It has a large standard template library. And I even have a C++ reference that I downloaded on my computer. It's actually an offline copy of a website. So I can look up everything in the standard template library if I want to use it. But the thing is, I don't really know how to use it, and I feel like learning to use the standard template library, first of all, that's going to take years of time I don't have. I don't even get the time to read my books very much. Second of all, if I can already do something in the C programming language by just writing my own loops with integer variables, why would I use C++? Now, Java is interesting because Java has been advertised as a write once, run anywhere language. And Java programs, they have a source code that's compiled into a bytecode, and then the Java interpreter interprets that bytecode. And it seems silly, but there's actually a really good reason. If you are a person who wants to write a program, maybe a game or something, and you want it to be able to run on the most computers possible, whether someone's Windows, Macintosh, Linux, but you don't want to reveal your source code, you've got to go with Java. And the reason is because the bytecode will run on any system that has a Java interpreter. So that's good if you're a closed source person. However, if you want an open source program, then you've got to go with C or C++. Because if you publish the source code to your program, then anybody who has a C compiler can do this, whether Windows, Linux, or Macintosh, or even other operating systems that are not part of the main three. So I actually have read a lot, and I've experimented with other languages too. JavaScript, PHP, Perl, Python. I've tried a little bit of everything. In fact, there's even a programming language called Brainfuck. It's literally called brainfuck. And, well, if you try to learn that programming language, you'll see why they call it that, because it's not easy on your brain. But anyway, so I've learned a lot about programming languages, and so far to date, my favorite is still C. And I actually have quite a few programs I've written in C. I would like to show you some things I've written in the C programming language, because I've written the most in that language than anything else. So I'm going to switch to my screen display. Okay, now hopefully you'll be seeing my screen here. I really hope so. Yeah. Okay, so there's my Princess Rosalina on my desktop. I have a whole bunch of desktop shortcuts. Okay, so I'm running Windows 10, which is a terrible operating system, and yet I'm always afraid that if I try to install another operating system, then I'm going to need something that only runs on Windows, like iTunes or Skype or something. Although Ubuntu Linux can run Skype, but I don't know. I have this system set up, plus I need Windows 10 for our printer. But anyway, enough about the operating system. Here's what I use. I have the most awesome setup. Okay, so this is a little bit of a folder that I have on my a shortcut to on my desktop. Now, these three shortcuts, they all will let me compile C or C++ programs. There's minor differences. This one will let me run programs, compile and run programs on my system, but only within the MSys2 system. It's MSys is basically a very stripped down version of Cygwin. Like, if you don't know what Cygwin is, then you can Google that. It's like CYG Win. But basically, this is a distribution that lets you compile and run C++ programs, as well as a lot of other tools. Like you can install things and stuff. Now these other two links, these are what I use, and those go to the compilers, C compilers that can produce executable files that will run on other people's computers. So if somebody has a 32-bit a Windows computer, I need to use this one to compile my programs before I send it to them. If they've got 64-bit, this will work. But if I'm just messing around by myself, this one works just fine. Okay, so MSys is loading up, and it takes some time to load up, especially while I'm recording with my Open Broadcaster software. Okay, so now here is a shortcut. And this is my home area it's like my home, like in my little Linux. It's a Unix type distribution. So here's the C folder, and here's the Unicorn folder. Now this is what I've been working on. Basically I have this folder, and here's the deal. See, when I do ls, it displays those folders that you just saw before. If I go to cd C/unicorn. Oops, I forgot to include the R. Then I do ls, and I wonder if dir does anything. Yeah, ls or dir both display those files. Now, check this out. So those files I can access from this terminal here, but they're also accessible from that window. So I'm going to show you something. Now, if I do /main, it runs the exe file. And you see that? It runs that program, and okay, wait. I need to expand this. Okay, so I can scroll through this. So see, that program, it generates this sequence of integers. And that's because I have the most excellent powers of 2 program that I wrote. And I'm going to show you the source code of this soon. Okay, but I want to show you something else. If I type cat makefile, it displays my makefile. And that is the thing, is this is a makefile. I wrote a makefile, and the advantage of using a makefile is that I can simply type make, M-A-K-E, and hit enter. and then it clears the screen, compiles the program, and then it should see that it displays the same thing. So it's a system that compiles and runs the whole thing. So the make file is actually very convenient, because the alternative, okay, I'm gonna start using Notepad++, and I'm gonna show you. So okay, so what it does here is when I type make, here's what it does. It does command clear, then it compiles the program, and then it runs it. Now, I can also do other stuff. So, for example, if I type make hello, then it displays hello world. If I type make clean, then it removed the main executable. So now if I type the /main, then there's no file or directory. And that's all because of my make file. The make file has saved me a lot of time, and make run actually does the same thing pretty much as the default one. It's just that it has the command to compile and run all as one line by combining them using the and symbol there. So anyway, enough about the make file. Now you know how the make file works, and let me make sure this is still recording. Yes, it is. Great. And you see why I needed to be uninterrupted, because if my mom interrupts me, I'm going to lose my focus here. Okay, so here's main.c, and then I'm going to open the other one, unicorn.h. So I'm going to show you something here. See, now notice here in the main function, this is a small function. Okay, I have I equals 8. And what that does here is I have this basic thing. This determines what it does. So if I equals 8, it will do the powers of 2 up to the 64th power. However, I can do better than that. I can make it go up to 200. So I'm going to save that file, and then I'm going to go back here, and I'm going to do make. And then, see what it does there? It displays the powers of 2 all the way up to the 200th power. Okay, it's very, very impressive how this works. Okay, so you see, basically, I can change the behavior of this easily. Okay, I'm going to set this back to 64, and I'm going to show you some other things. Like, for example, if I set I equal to 0, and then I do make, it's going to do something. It doesn't do anything, but basically it's asking for a number. I can type nonsense, like, okay, nonsense. And it thinks the number is 0 because it's not a number. Now let's do this again. And now if I type 579 and hit enter, then it displays the same number. And that's because all it's doing is it's calling the getInt function, and then it's doing the PutInt, and it's putting a new line character. And if I change I to 1, then it does that. And that displays the prime numbers. I kid you not, it just literally displayed the prime numbers that fast. See, if I just do, okay, for example, if I type main, it doesn't do anything. If you're on a Unix, you have to do /main, and I'm mistyping it. It literally displayed all those prime numbers that fast. And why does it do it that way? Well, I'm going to show you something. The powers of 2 program, as well as the prime number program, I have the full source code. And I have some other things here too. They're very simple. So I'm going to go through one more of these, because there's all kinds of stuff. Okay, so if I is 2, then it calls the bink function with an argument of 5. Okay, so now if I do it that way, 5. Notice it does binary counting sequence in 5 bits. If I change that number to 8 instead, then it's going to display it's going to count in binary all the way up to 255. Basically the highest number that can be represented in 8 bits. So see, these 3 programs, well, there are 3 functions. Before I've written entire programs that were devoted just to them, but then I combined them into my Unicorn project. And the Unicorn Project, of course, is named after the mythical horse known as the unicorn. But it actually has another meaning. I'm going to show you the source code that generates the powers of 2 and the primes and the binary counting sequence. So this could be like a sort of long video. Okay, well, first of all, this in the main file, it includes these files from the standard C library. Okay, and then it includes unicorn.h. Now, unicorn.h, everything in there is all my code. It's all my source code that I've been working on. And this has taken a long time. I have some comments here that describe things. Now, so here's how it works is, it's very funny what I did here. I made an array. Now, this is a constant of 65536, 2 to the 16th power. And I can always make the number higher or lower in the source code whenever I feel like it. And then this is the horse array that is always set to be of the size that's equal to the unicorn length. Now it's a char array, and that means it's a byte array. A character in the C programming language means 1 byte, and so 8 bits. And char arrays are useful for me because of the kind of programs I write, because I can use a short or an int or a long for this array, but that uses more memory needlessly. I don't need that. And then we have a char pointer. That asterisk means pointer. It's a char pointer, a character pointer named unicorn, and it's equal to horse. That's because I'm making this pointer equal to horse, and that means that trying to index by the pointer or the array is absolutely the same thing. It's just a synonym for it. However, pointers have other uses, and I've learned a lot about pointers from the C programming language. And the C++ programming language has pointers too. Java does not have pointers, which I feel is a weakness of the language. But anyway, enough about pointers. This was just a joke. By having an array named horse and a pointer named unicorn that points to it, I'm just being funny. Okay, so then this is a smaller array, and this one is unicorn string length, the constant, and then unicorn string, and then unis. Now I'm going to tell you something. The names I chose for these variables are actually very clever. Okay, so a unis is basically, it's a short way of saying a unicorn string basically, but it's also used. Let's see. Okay, wait. Oh yeah, that's the pointer to the unicorn string. So it's basically it's just the same thing as what I did up here. Now next come the unsigned int. Unix, uni-y, and uni-z. They're all uni, and then see what I did? X, Y, Z. And I have this thing about X, Y, and Z because of Minecraft and the coordinates being referred to as X, Y, and Z. So, and they're the last 3 letters of the alphabet. Now I'm going to show you I have several different functions in this file. Now this one, this is a function that I created, and this displays numbers to the standard output in decimal without using a call to printf. I literally wrote my own routine. So it basically, all it's doing is let's see here. Okay, I better not try to explain all the source code, but here's what it's doing. Basically, it puts 0 on the string, and then it does this loop, and it goes downwards through the string to lower things, and what it does is it keeps dividing the integer by 10. It gets the remainder of division by 10, and then based on, okay, I forgot what this does here. Okay, So I forgot. Oh, I know. I used to know how this worked. Okay. Oh, that's interesting. Oh, I remember what this did. Oh, this was something in here that only applied to negative numbers, because this function used to account for negative numbers, and you can see that. It used to put a minus sign as well for negative numbers, but I changed it to unsigned, so this doesn't actually do anything. It's still here. And then what this does is it takes the remainder of the division. Yeah, see, it stored the remainder of division, and then it adds this character value to it to make sure that it will display as the correct ASCII value. And then after it's done that, it gets the remainder, and then it stores that particular digit in the array to display, and then it will divide. It will actually divide the integer by 10. It does that through a loop, and that's why it works. And then after it's stored all of them, then it prints them out in the reverse order to make sure they display in the conventional order. It's actually one of my proudest achievements. And what I showed you earlier, how I did the getInt and PutInt and then PutChar with 0, it's possible now for me to do my integer sequence programs using entirely my own input and output routines that only use PutChar and GetChar. It's unbelievable. It's possible to do it without printf, although using printf is easier, and I still use printf a lot. So there's the PutInt function, and here's the getInt function. And here's what it does is it has an integer which is set to 0. And then what it does is it gets a character, and then it does a loop that skips the white space. So it'll skip any white space it encounters, any non-displaying characters. And then after that, then it does this loop that while the character is within a certain range between these ASCII values, it will interpret it as a decimal digit. So then after it does that, then it subtracts this value, and then it will multiply the number by 10 so that let's see, I forgot. Oh yeah, it multiplies the number by 10, and knowing how this works exactly and how it stores the integer, you really have to understand something a little bit about like binary to decimal conversion. But yeah, inside the code of the printf and scanf functions, which can do the same thing, somebody somewhere had to write code similar to this. And so yeah, basically it allows a user to type in the number, and then it displays the number. And I proved to you earlier that it worked, because first it calls the getInt function, and then it puts that same integer to the screen. And of course it puts 0 if you put something in that's not a number. And it's simple why it did that, because think about it. If somebody enters a character of the alphabet, this loop is going to terminate immediately. Then it's going to return that value of I. And so basically that's how it works. So my PutInt and getInt functions, those are important to me, although they're not essential to my other programs, just because I can do it without using I can use printf and scanf for simplicity. I don't have to use those functions I wrote. Oh, and here's another one. This is powers to tiny. And I'm going to change I to 7 here. And I'm going to show you when I do make now, it displays the powers of 2 up to the 64th power there, which is really kind of cool. Slightly less. That's actually to the 63rd power. But anyway, see, this was just a test. The power's too tiny. See how tiny that function is? It's very tiny, because all it does is it defines a variable named x, and then it sets it to 1, and then while it's not 0, then it displays it and then adds it to itself, and then puts the new line character. And the reason that the loop ends is because x will become 0. Because eventually, any power of 2 when doubled will eventually pass over the limit of what the integer bits allow, and it will become 0. So that's a very clever function that only works because I know how binary works in computers. Now, if it was any number that was not a power of 2, well, then it would be a problem, and it probably wouldn't work very well. Now, this is what I call the ultimate powers of 2 function. Perhaps one of my proudest achievements, maybe even more than the PutIn function. And you saw how my program could display the powers of 2. Let me make sure this is still recording. This should be recording. Yes, I think it is. Okay. This powers of 2 program here, what it does is it basically first fills the entire unicorn array. Those global variables that I showed you earlier, I'm going to show you these again. This array, the unicorn or the horse array, same thing. Basically, I use that array in my powers of 2 program, as well as in my binary counting program, and so forth. Okay, so what it does is first it has this loop. What it does is it uses Unix or UniX as the variable which is an index to the unicorn or horse array. Either way, I'll call it the unicorn array. So while first x, well, I'll just call it x to save time here. Okay, so while x is less than unicorn length, the length of the entire array, it will set each element of it to 0, filling the entire array with zeros. And then after that, it sets the very first of them to 1, and that will be 1. And then this variable, I'll explain that one later. But then it does this loop. This loop basically, the z value here, this keeps track of the exponent, basically. It will display the exponent, because you saw earlier it displayed the exponent of the power of 2. So what it does in this loop is, first of all, it displays it. And the UNY value is important because I only want it to display the ones currently used. I don't want it to display a whole bunch of zeros. So it sets it to 1, and then it does this weird loop so that first it prints the UNIZ value, or z, whatever, let's call it z. And then, while this number is greater than 0, first it subtracts 1 from x, and then it prints that particular index, and once it's done printing it, it displays a new line. So that's the display. And then it sets, okay, now this one here, okay, I forgot exactly how this worked here. So it sets that particular 1 to 0. That's interesting. That's very interesting. I'm not entirely sure why this is here, but I'm not going to remove it because it's probably important. But yeah, so that'll, whatever unit y is, or y, that will set that element to 0. And then here's what it does. It goes through each element, starting at the lowest one, at element 0. It goes through it and multiplies it by 2. I could have added to itself or done a left bit shift by 1 bit. There's 3 ways that work, but I just did it this way. Okay, so and then what it does is, I remember this. It's using this one. This is the carry variable. Okay, if you've done addition, what's referred to a carry. That's right. It uses an element of the array as the carry variable. That's what it did. Now I remember. Sorry about that, people. I've forgotten how my own code works. Being a programmer and having a poor memory is a really bad combination. Okay, so what it does is it adds that carry variable, which at first it's 0. But then here's what it does. It has this if statement. If that particular element, that particular digit is 10 or greater, then it does something else. Then it sets the carry variable to 1, and then it subtracts 10 from that. Because remember, each element of the character array is meant to represent a number 0 through 9, that decimal digit. And so it has to, in order to display correctly, it has to do that. And however, if it's less than 10, if it was not greater than or equal to 10, then it sets the carry to 0 instead. So this if statement is important. And there are other ways to code this, but the if statement I like, because if statements are very important in computer programming, the ability to conditionally execute different codes. Okay, so what we have here, and then here's what it does. If the carry variable is 1 there, then it adds 1 to y. It increments it by 1. And why is that important? Well, I'm going to show you again. See, my powers 2 program, this ultimate powers of 2 program, what it does here is okay, so here's what you're going to see. You'll probably notice in this program it runs. I'm going to show you this again so you can visualize how it's actually working. This powers of 2 program, I've worked on this program for years, believe it or not. Every once in a while I'll go back and add comments and I'll change the code, but I've been working on the same function for years. I've gotten it to display all the digits correctly, but I'm always trying to find improvements for it. I'm like a perfectionistic computer nerd. Okay, so what you see here is y starts out as 1. You know why we'll refer to as y. It starts out as 1, and that means it's going to display 1 digit. But then if the carry variable is 1, then it has to display 2 digits the next time. And I've conveniently made it so that basically so that the carry variable, which was 1, automatically happened to be the index of the y value of that same array. So it's automatically set to 1, or whatever the case may be. So then it does the same process. So that's how it works, is that y, every single time it repeats, basically, is how it works. And that's important because it needs to display more digits. So that y variable keeps track of how many digits are going to be displayed, and the z variable is the current exponent. And so it does that, and this can go literally as many digits as the array allows. So you can have powers of 2 up to millions of decimal digits, whatever your available computer memory allows, basically. And I would need to make the array bigger, but I have the source code. I can do that. Okay, so that's basically how it works. Now, so it's a very powerful program. It's one of the most powerful programs I've ever written. And let me show you something. I can modify this. For example, if I try to set, instead of this, let's suppose that I set unit x to 20, then I'm going to show you something. I'll just quickly save that, and then I'm going to run this again. And then look what it does. Notice now what it does. Now it always displays exactly 20 digits, including the zeros. So I can modify it by that simple change to display the exact number of digits that I want to display. So this function is highly customizable. Okay, so yeah. It all works here. So let's see what we have here. So yeah, basically, that's how it works. This powers of 2 function, I need to catch my breath. I'm talking too fast. Okay, so this powers of 2 function, this function, this can display the powers of 2 using only the C standard library. And this one uses printf for simplicity. Basically, I didn't have to use printf because I've written my own functions instead, but this one is simple. So anyway, that is the powers of 2 program. Now let me look at the length of this video, because this video is already over 40 minutes, and people get bored with long videos. In fact, anybody watching this, you're probably still bored out of your mind unless you're a hardcore programming nerd. So what I'm going to do is I'm going to stop this video, and then I'm going to record another one after this to show how the prime number programs work, and maybe I can cover that and the binary counting program in the same video. So I'm going to stop this. I hope you enjoyed this.